Hello everyone, welcome to this KANPUR-NPTEL online course on space environment and its effects on orbital spacecrafts. So, this is the third lecture of the first week and we are discussing a few topics especially related to sun and its activities, which are very much relevant to understand the space weather and its effects on orbital spacecrafts. So, we discussed about the anatomy of the sun, what is the internal zone of the sun and how the charged particles are generated inside the core of the sun and how it propagates to the atmosphere of the sun, that is the corona. And in this regard, we defined the sunspot and the sunspot cycle, also we called it the solar cycle. So, while discussing the solar cycle in the last session, we discussed solar activities. Solar activity in terms of solar wind. Solar wind means this is the flow of or the emission of charged particles from the solar atmosphere, that is the corona, and it spreads throughout the interplanetary space in our solar system. And this solar wind it is always there, like as I compared it with the breeze in our atmosphere, like the air, it is always there, but there are sometimes depending on the solar cycle or the number of sunspot cycles, the phenomena like solar flare happens. So, what is solar flare? As we explained, the solar flare is the sudden outburst or the brightening of the sun, whereas in that phenomena the radiation, that is the powerful the radiation at different spectral wavelength like the X-rays, UV rays, then the radios. So, these are the things it is emitted those radiations and it again it spreads to the whole interplanetary space. Then we described a phenomena that is called the coronal mass ejection. So, that is the mass loss or the mass ejected from the atmosphere, that is the corona. So, we defined how these two are the different, what are the time scales. Then we defined or we discussed the solar energetic particle events. So, we said that those particles which are having the energies more than some 100 kilo electron volt to some giga electron volts. So, these are particularly separated or it is also called a that is the solar activity, that is the solar energetic particles, where the very high energetic particles are emitted from the atmosphere of the sun. So, we will proceed further in the same topic. So, we will now today discuss the interplanetary magnetic field. So, as I said, since there is the movement of the charged particles, so whenever the charged particles are moving, there must be the magnetic field. So, this moving charge and magnetic fields they are related, they are correlated. You cannot have a moving charge or the current without magnetic field. So, now how this is interplanetary and how it comes the solar magnetic field comes to the interplanetary region and it spreads throughout the interplanetary solar system, that we will try to understand. So, in order to understand that, we will also discuss the co-rotating interaction regions. And in order to explain this phenomena, we will need the topic like to discuss, that is already we said that is the outermost zone of the sun or is the corona. So, we will discuss a little bit more detail about the corona and the coronal structures. So, coronal structures we will discuss what is coronal loops, then Helmholtz streamers, then coronal holes. Okay. Now, we will discuss though we have already said about the corona zone of the sun, that is the outermost zone of the sun. So, here we know that is this corona of this it is already, as I said, it is the outer atmosphere and it is usually hidden by the bright light of the sun surface, that is the photosphere. So, because of this it is very difficult to see that without using the special instrument. So, I will just explain what is that special instrument, but it can be visible during the total eclipse. So, during the total eclipse we can see it as as a you can see this is basically the color is something like orange or so light yellow or the purple color. So, this type of the thing it is because of the different the spectral lines, that is the radiation from the different the spectral lines, this give rise to this type of this color, but for that either you can see it during the eclipse or using the special instrument called the coronagraph. We will just explain it subsequently. This corona, it displays a variety of features. So, you can see here this there is a variety of features. So, we will explain one by one. So, this can be that is the streamers. So, you will have that is the streamer, that is the this is the flow of those the plasma, it follows a particular the streams. So, that is called the streamers, then the plumes and the loops. So, we will explain one by one. So, this corona, this or the heliospheric atmosphere, this extends far out, and the shape of the corona, which extends to several solar radii, it depends on the sunspot cycle, means the number of sunspots, because as we have seen the number of sunspots is changes with the sun cycles maximum to minimum. So, this the shape of this corona, it is strongly a function of the sunspot cycle, and it is this coronal structure is more spherical during the solar maximum of the sun. That is when the solar maximum means the number of sunspots will be the maximum. So, this whatever I was saying, the different features, you can see there is the lobes, then the streamers, then some open magnetic lines. So, this will explain one by one what are those. You know already that is the corona is it is having very high temperature, that is around to 1 million degrees centigrade. So, because of this the coronal gases they are superheated. So, what happens because of this superheating? So, at this high temperatures both the hydrogen and the helium, which are the lighter elements, these are the two the dominant elements as already we said. So, they are completely stripped of their electrons. So, they cannot have any electron in their atomic structure. So, only the nuclei will be there and the rest the electrons. Even these minor elements which are heavier elements, that is the carbon, nitrogen and oxygen, they are also stripped down to the bare nuclei. There are some heavier trace elements like iron and calcium. They are able to retain a few of their electrons in this intensity, but they are also not they cannot remain in the neutral state. So, it is this emission from these highly ionized elements that produces the spectral emission lines. So, in order to view the coronal zones, artificial eclipses are produced. So, whatever I was telling the special instruments. So, how it is done, that is using the instrument called the coronagraphs. So, in that instrument there is a disc is used which covers the sun disc and filter out everything except the emission due to this coronal ions. So, this coronagraph produce the images of the emission line of the corona. So, you can see this type of the emission lines, this can be visible using the coronagraph instrument. Now, just what is X-ray corona? So, the corona this shines brightly in X-rays because of its high temperature. And on the other hand, the cool solar photosphere they emits very few X-rays. So, that way it can be differentiated. So, this allows to view the corona across the disc of the sun when we observe the sun in X-rays. So, what is to be done in order to to observe the X-ray lines in the corona atmosphere? So, what is done actually? So, the optics is designed so that you can have that that observation or the filtering of the other wavelength which can image the X-rays, and then you must go outside the Earth's atmosphere, because being in Earth's atmosphere you cannot observe this X-ray or the other spectral lines, because all these things will be absorbed by the atmosphere. So, in early 70s this Skylab that it carried the X-ray telescope, and that revealed, in fact, through that only we could come to know about the coronal holes and the coronal bright points at the first time. And during the last decade this YOHO, that is instrument provided the wealth of the information and images on the sun's corona. So, this is the image from the soft X-ray telescope on board the UOCO. So, it shows the X-ray emission of the solar corona in way back in 1992, and this UOCO, this is it is also called this Sunbeam. It was a Japanese solar mission with USA and UK collaborator. So, of course, there are the other observatories like SOHO, then TRACE, then Solar Orbiter, Parker, Solar Probe, then Aditya L1 satellite. So, all these things and others are also used to obtain the new and exciting observation of the sun's corona, its feature and its dynamic character. Now, let us see what is the coronal loops. So, coronal loops, these are associated with closed. So, loop means it has to be associated with closed magnetic field lines. So, that connect the magnetic regions on the solar surface. So, that already we have seen that two sunspots they connect the so magnetic field are looped between two the sunspots. Okay. So, you can see here these are this some form of these loops, but that they are not the magnetic loops. So, this is again the observation in the X-ray wavelength. So, what happens in the corona of the magnetic field, this in which this motion of the plasma is magnetic field, it dominates the motion of the plasma pressure. So, the Lorentz force or the magnetic force on the plasma, there is more than that the plasma pressure, and because of that the plasma is aligned with the magnetic loops. So, these are the frozen, the magnetic field and the this plasma are the frozen in the magnetic loops, and this hot plasma this causes the loops to glow in the extreme ultraviolet or X-ray portions of the electromagnetic spectrum, and which can be observed through using the telescopes at which are tuned at those frequency those wavelengths. And these loops it can last for few days to weeks. Of course, there are some loops can be associated with solar flares and visible for much shorter periods, that we have seen that the solar flare this time scale is small, it can be even just an hour or even lesser than this. And these loops they contain the denser material than their surroundings. So, coronal loops are frequently associated with a sunspot, as at the very beginning I said. So, coronal loops often arc between pairs of sunspot with opposite magnetic poles. Now, let us try to understand what is this helmet streamers. So, these are the large cap like coronal structures, which will show the schematic here, but already we have shown in this previous slides. So, which are those actually? These are having long pointed peaks. So, they are found usually over sunspots and active regions, and they are closed magnetic loops which lie above the divisions between the regions of opposite magnetic polarity on the sun surface. So, whenever there is the opposite magnetic fields, so there has to be the current in between, that will be given by the Ampere's law. So, you can see here this pointed peaks. So, this shows the pointed. So, this I can say these are the helmet streamers. So, this so I mentioned these and these are this forms the helmet streamers. So, you can see this diagram, so or this schematic. So, you see this is the magnetic field of this opposite directed. So, in between there is the plasma sheet or the current sheet. So, this is called the helmet streamers. So, how these are formed? So, these are formed by a network of magnetic loops that connect the sunspot in the active regions and having the oppositely directed magnetic field lines. So, this closed magnetic field lines that trap the electrically charged coronal gases to form these relatively dense structures. And how the pointed peaks are formed by the action of the solar wind blowing away from the sun in the spaces between the streamers. So, this is what I was trying to mention. So, this is the current sheet and or it is also called the plasma sheet. So, they are between this between the oppositely directed magnetic field lines. So, this slow solar wind, it originates from the closed magnetic field lines at the base of the helmet streamers. They are confined to low latitudes. So, that will come to this thing, that is the slow solar wind as well as the first solar wind when we will discuss the coronal holes. So, means closed magnetic fields, that the whatever the solar wind is associated with the closed loop, they will have the lower or they will be slower or they having the lower energy. So, during the solar minimum, the helmet streamers are found closer to the heliographic equator, that also we will see through a schematic in the subsequent slide. So, this helmet streamers, so basically now you can see here these helmet streamers, they are distributed over this corona regions, but during the when the solar minimum, they will be aligned to the equator, and this then we will see that open magnetic field lines, they will be oriented in the polar region. Now, we told in the in the previous slide about the pseudo coronal streamer, that is the helmet streamer as well as the pseudo streamer. Now, just we will try to differentiate between these two. So, the two streamers what we just that is the helmet streamers, which are long lived and relate to the global dipole magnetic field of the sun, and it that is the separate regions of the opposite magnetic fields in the coronas. Whereas, the pseudo streamers, they are transient, they are not long lived or the stable structures that separate regions of the same polarity. So, if it separates the same region, the magnetic field of the same polarity, then there will not be any current sheet as like we have in this the true streamers or the helmet streamers. So, you can see it here. So, this is the streamer. So, you are having this magnetic field, opposite magnetic field. So, this is this direction magnetic field, this is in this direction. Okay. So, so this shows this direction, it's upward and this is downward. So, you are having a current sheet in between, and in between this CH means here CH is this is called the coronal holes. We will explain what are those in the subsequent slides. So, you can see here the pseudo streamers, the magnetic field, they are in the same direction, and you see that how the loop is formed here. Okay. So, this differentiates the pseudo streamers from the true streamers. So, the streamer identification if I want to do, so I will refer to this figure where the parameter ds that is called the identification parameter. So, you can see it is the distance between the photospheric foot points. So, this ds, so this is larger ds, this is the small ds, and we will see that small ds. So, this corresponds to this coronal holes. So, small values of indicate the mapping of the coronal holes, which I will be explaining in the next slide, and the large values indicate mapping of the base of the either a streamer or a pseudo streamer. Streamer means where the magnetic, so it is in the magnetic field lines are in the opposite directed magnetic field lines, whereas the pseudo streamer where the magnetic field lines are in the same direction. Okay. So, this already I said about how they are, these two are distinguished by the polarity of the magnetic field and the current sheet. And these streamers, they separate the coronal holes of oppositely polarity and encase the heliospheric current sheet. So, this is also we have seen it here as well as in the previous slides. So, sometimes these are called, these two streamers are also called the dipole streamers to distinguish from the pseudo streamers, which separate coronal holes like the polarity and contain no current sheet, as I told about this. So, there is no current here. So, this I was mentioning. Okay. Now, whatever we mentioned about the coronal holes, let us try to understand what we call the coronal holes. So, coronal holes, these are the region of very low plasma density in the corona atmosphere that shows up as a dark region in the X-ray images. So you see there are these are the dark regions. So, this will be defined as the coronal holes. Now, let us see how these are formed. So, these regions, whatever I said, these regions, they corresponds to the solar magnetic field which extend radially away from the photosphere, and we will see that they are not the closed magnetic field lines, but they are the open magnetic field lines. So, this plasma density here is due to the radial nature of the field. Plasma escapes by moving along the magnetic field line. And because of this, so this is the low density, that is the plasma or low density the charged particles, they are directed or they are guided by the radial nature of the magnetic field. And so, this gives you the directed beam of very high velocity plasmas. So, in the coronal holes, whatever the plasma they are having very high, there is the high velocity or the high energy plasma as compared to the surrounding regions where there are no the coronal holes. That is why these coronal holes, these are understood to be the source of high speed solar wind particles. They are constantly emitted into the space. So, once sun's magnetic field lines in these regions open up, they allow charged particles to stream out from the corona into the space. So, as I say, these are not the loops, but they are the open magnetic field lines. So, these charged particles, these are mostly electrons and protons make up the first solar wind. So, this is important, this is the first solar wind. They are particularly prominent near the sunspot minimum and near the solar poles. So, this is the clear when there is the solar maximum. So, you see there are these are the various the active regions, and then we are having the coronal holes. They are these are this shows the coronal holes. So, this region, then this region, these are the coronal holes, whereas when the declining phase. So, you see this this coronal structure. So, here it is, as I said previously, it is mostly spherical, but now then it is becoming it is getting the localized those and at the solar minimum, you see it is basically in this region, and you are having this is the that is the open magnetic field lines, and this is giving you the this gives rise to the coronal holes in the polar region. And so, this shows you a 3D of those. This is the 2D cut. So, this is the 3D visualization of whatever I said. Just try to explain what is the interplanetary magnetic field. So, already you know this is the magnetic field that exists in the space between the planets within the solar system. So, this is the component of the solar magnetic field that is dragged out from the solar corona by the solar wind flow to fill the solar system. So, in the solar corona, that is the magnetic field pressure greatly exceeds the plasma pressure that we already told, and thus the plasma is primarily structured and confined by the magnetic field. But what happens with the increasing altitude through the corona, the solar wind accelerates as it extracts energy from the magnetic field through the Lorentz force interaction, and resulting in the flow momentum exceeding the restraining magnetic field tension force, and the coronal magnetic field is dragged out by the wind to form the IMF. So, this magnetic field is pulled out into an Archimedean spiral pattern. So, this was this was proved, or this was mathematically found by the Parker, and it is that is why it is called the Parker spiral. So, we can see it here, you can see this magnetic field is, and we will see that it co-rotates with the rotation of the sun. So, this is the general structure. These are also called the Parker spiral interplanetary magnetic field, and you see how they interacts, and this magnetic field that is the coronating magnetic field, that which are called the interplanetary magnetic field, they reaches to our Earth, that is atmosphere, and then or in the Earth's magnetic field, and near the Earth space this interplanetary magnetic field, it makes an angle of approximately 45 degree to the Earth sun line, and of course, this angle varies with the solar wind speed. So, fact about this interplanetary magnetic field. So, since the sun rotates, so 25 days period at the equator, and we know at the polar it is at 27 days. So, solar wind that flows out radially with magnetic field frozen in it, and the field lines tied to the sun. So, rotation results in a spiral magnetic field. So, the resultant field is like a long sprinkler. So, the Eugen Pager theorized this in 1950s. So, this I showed you in this place. So, you can see how from this is the coronal law of how the magnetic field lines form. So, you see there the two color magnetic field. So, they are the oppositely directed. Okay. So, that is why between two we are having heliospheric that is the current sheet, because these two magnetic fields are of the opposite direction. So, we are having this the current sheet in between. So, this shows a 3D of this interplanetary magnetic field. Now, we will see that how it this interplanetary magnetic field it interacts with the geomagnetic field. So, just will of course, we are considering it is parallel, but you assume that this angle is the 45 degree with the sun and the earth line. So, now here it shows that this interplanetary magnetic field is southward. Now, our geomagnetic field it directs from the that is the geographic south pole to the north pole, or magnetically it is just the opposite, it is the north to south, magnetic north pole to south pole, and these two are in opposite direction. So, whenever the magnetic field lines, two magnetic field lines they are in the opposite direction, so there is the magnetic reconnection happens. So, because of this magnetic reconnection happens, the magnetic field lines will get opened here, and then the particles they will get that magnetic field energy that will be converted to the, it is called the that is the kinetic energy or the thermal energy of the solar wind. So, this reconnection, so this is the reconnection. So, this happens at the magnetopause boundary between these two plasma regimes. So, the reconnection that occurs in a small region where the plasma becomes demagnetized, creating open magnetic field lines. Okay. So, this how the reconnection point it happens here, that is shown when this IMF and this our magnetic field. So, they are in the they happens in the opposite direction. We can show it for the other cases also, maybe in the subsequent lectures we will show it. Now, one concept, this is called the co-rotating interaction region. So, the co-rotating interaction regions are the long lasting large scale plasma structures. They are generated in the low and the middle latitude regions of the heliosphere. So, we have seen there are two types of this solar wind. The first solar wind in the which is generated in the region of the coronal holes. So, because of this interaction between this two slow and the first solar wind, so there is an interaction regions because of the dynamic interaction of the solar wind stem, and then what you have because of this high speed solar wind, which are because of this which are the source is identified as the coronal holes with their open magnetic field structures. And then this origin of the slow speed solar wind is less clear. Of course, these are was already we discussed, these are associated with the generally the closed structure, closed magnetic field structures. So, co-rotating interaction regions are the structures formed when the high speed solar wind streams they overtake the solar wind streams as they propagate outward. So, these structures produce the regions of enhanced density of magnetic field strength, and they co-rotate with the solar. So, that is why it is called the co-rotating interaction region. So, we can see this whatever I just discussed from this picture. So, maybe in the next session we will discuss this in more detail. So, just today let me finish it here. Thank you very much.